With an understanding of mathematical expressions written by somebody else, we are at a mature stage where we can actually attempt to write mathematical expressions of our own. In this module, we shall try to move in a stepwise manner to make equations that are simple yet purposeful. We shall know what are the constituents that we must take care of in an equation. Once we are comfortable with that, we'll take some tips on easy math writing. An equation is actually a statement that comprises two mathematical expressions written on both the sides of the equal sign. It means we have a right-hand side and we have a left-hand side. Both of these actually equate each other. One wonders, if we have seen equations, then what about the formulae? A formula is actually a recipe for doing some operation. To relate, for example, you know that there are various formula which exist for making medicine. That formula is represented or can be represented through mathematical representation in which each ingredient has a certain percentage that added together would make that particular medicine. So a formula in terms of equation is what sits on the right hand side of the equation, consisting of various independent parameters and variables, whereas the result is passed on to the left hand side, which is the dependent variable. An equation may consist of some or all of these constituents. In an equation, we can have constants from any numbering system. We can have variables which give names or symbolic names to some functions of that system under consideration. We have mathematical operators such as unary and binary operators. Then, if these binary operators are grouped together, these are called functions. And lastly, the conditional expressions. These conditional expressions are present in an equation, but are used or are activated according to a certain condition if it exists. If a certain condition does not exist in a mathematical equation while it is being processed, the condition is not fulfilled, so the conditional expression is simply ignored. Here we start with the first and the most widely adopted mathematical writing skill. It is called the 2-3-4 rule. Here, 2 implies that if we have a sentence that is spread over 2 lines, it must be broken down and split into 2. Likewise, if we have a sentence of such length that it contains 3 verbs, 3 actions, it means it must be split and broken down. And lastly, if we have a paragraph that comprises 4 long sentences, each of these sentences must be broken down so that the paragraph becomes more discrete. This 2-3-4 rule is applicable once you are given a text document or a scenario which is expressed in narration and you want to mathematically model it. The next trick is to use mnemonics. Mnemonics imply certain recollection strategy which helps you to immediately recall what the mathematical equation is about. For example, if you were to represent the relationship between speed, distance and time, or velocity, distance and time, then mnemonics imply that you should use the most appropriate variables. For example, S has to denote speed, V for velocity, and T for time. Mixing up these or not taking care of these could actually hinder your understanding, and you would not be able to make a mathematical expression that is easier to understand by others. And then, when we look at a document or a scenario that we need to model mathematically, we must focus our attention to making some segments out of it. What are segments? Segments are actually independent mathematical expressions which have been derived from a text document, which are autonomous or independent in their structure. It means they have a start, they have an end, and they have a clear message to give. Since each segment may consist of at least one or more equations, so the variables, the parameters, the constants, everything included in there serves like arguments. Now these arguments of a certain segment have to be organized in a way that the reading by others becomes easy. In order to do that, the most recommended strategy is that segments should be represented linearly. However, there are other representations as well. For example, the arguments within a segment could be related to each other in a hierarchical way. Here we see that there are level 1 arguments, level 2 arguments, and finally these are transitioning into the end of the segment. Here we see that there is a many to one relationship that exists between these arguments. Specifically, you can see that argument number 1 at the first level is connected to the argument number 3 and 4, whereas argument number 2 is just connected to argument number 4. Making such hierarchical relationship for a segment makes the understanding of arguments slightly complex. There is yet another way, though not recommended much, which is nonlinear representation. Here, a depth-first alignment of the arguments within a segment are given, but these have been arranged as such that there are so many crossings. Crossings imply, for example, if you look at argument number 1 is connected to argument number 4. Similarly, argument number 2 is connected to argument number 4. As a consequence, we see that there is a crossing. This crossing, when represented in the form of complete segment, aka a mathematical expression, it is going to make the understanding a little complicated. So what is the best strategy? The best strategy is actually to go linear. The arguments within a segment are beautifully placed in a linear order.